So the first part of this video, we're going to talk about uniform distributions, but overall this section is called properties of normal distributions. So what is a uniform distribution? Suppose your friend is always late, and X represents the time from when you're supposed to meet and with your friend until the time he shows up. If X equals 0, your friend came on time. If X equals 30, that's the latest he's ever shown up. And the intervals of time are equally likely. Because any two intervals of equal length between 0 and 30 are inclusive, meaning 0 and 30 are included, he can be 30 minutes late, are equally likely, the random variable x is said to follow a uniform distribution. Okay, so a probability density function is an equation used to compute the probabilities of continuous random variables and must satisfy the following two properties. The total area under the graph of the equation over all possible values of the random variable is equal to 1. The height of the graph of the equation must be greater than or equal to 0 for all the possible values of the random variable. Okay, so area under the curve. So if we look at this picture, the area of rectangles is defined as A is equal to B times H, which is the base times the height. You probably heard that if you've been in geometry before, where B is the length of the base and H is the height of the height. We know that since the probability must add up to 1, the following rectangle emerges, and the probability, and knowing this makes this a probability distribution function. So what you see here is that there are 30 minutes. Oops. If you look on the far right at the bottom, you have 30 minutes. If you look at the top left, you have 1 over 30. The reason we can assume it's 1 over 30 is because it's equally likely for any minute between 0 and 30 that this person shows up. So it's a 1 out of 30 chance that they come at 0 or on time. If they come 30 minutes late, it's a 1 out of 15 or 1 out of 30 chance that they come at 15 minutes, and so on and so forth for each minute. So what is the probability so refer to the situation in example 1. What's the probability your friend will be between 10 and 20 minutes late? It's 10 a.m. There's a 20% chance your friend will arrive within the next blank minute. So let's go to, let's get out of this. Okay, there we go.
I can learn to understand you much.
Sorry, just closing that out. So let's look at this. We wanted to know the probability that the person comes between 10 and 20 minutes. So we can do that by looking at the area of this equation. So we've got the top, so we've got this going on. This is what we're looking at. Let me make this nice actually. So let me turn on shapes. So if we draw a rectangle, and we've got 1 over 30 being the highest part, we've got 10 to 20 here, then the distance from here to here is 10 minutes. And since this height starts at 0 down here, this is 1 over 30. Okay. So what is the height? This is 1 over 30 times 10, which is 10 over 30, which is 1/3, which is 0.33 repeating. Okay. So what does that mean? That means there's a 33% chance, 33.3% chance that your friend arrives between 10 and 20 minutes. Okay, so now for part B. Remember, it told us that there's a 20% chance that they arrive on time up until a certain point. They want to know what time that is. So if we have this, let's draw the picture. Okay, if we have this picture, we have 1 over 30 and 0. You have 0 here and x1. And then we have that this inside part is actually 0.20 So the area here is 0.20. So we know that base, let me do this, I'll do this in black. We have base times height is equal to 0.20 in this case. Okay, so now we know that the height here is 1 over 30. And we know the base starts at 0, so it's going to be a distance. It's going to be x1 minus 0 times 1 over 30 is equal to 0.20. And the reason that is obviously is because the distance between x1 and 0 is however far it's going to be. So to finish this, we have x1 times 1 over 30 is equal to 0.20, which is 20%. So we need to multiply both sides by 30. That will cancel. This gives us x1 is equal to 0.2 times 30, which is 6. So then x1 is equal to 6 minutes. So there is a 20% chance that the person will come between 0 and 6 minutes. Okay, I hope that helps.